introduction to your question, say we have a graph, and this one just happens to be a tree, and you start possibly with a breadth first search, and so you would say this is A, B, and C. You would start with this being your level 1. You start with A, and then you use a depth first search, so you go to B, then you return because B has no neighbors, and so in level 2 you would mark B as being a distance of 1 away from A, and then you return to A, and then you go to the next neighbor of A, which is C, and then you return to C from C because C has no neighbors, and so then you would have a level 1 and level 2 combination of breadth first search and depth first search. Now, it kind of just looks like you could have just used any of the singular algorithms and it would have just been equally fine. But perhaps in a different graph, say you have something like this, it might get a bit more complicated. This is A, B, C, D correspondingly. So you start with level 1 being A, and you go to using your depth first search to B, but you need to mark the distance of 1 out, because now you have to choose, do you return to A or do you go to B's neighbor? Do you continue doing depth first search, or do you return to doing breadth first search? And that's kind of the question. And so then you go to depth first search, and you'd have to mark it. Say we did that. Say we go to depth first search again. You'd need to mark that this is a distance of 2 away, and then correspondingly you'd have L2 and L3, and L2 would be B, and L3 would be D. And then since D has no neighbors, you return to B. Since B's neighbors have all been checked, you return to A. And then you again go back to C using a depth first search, and you add C because it's a distance of 1 away into your level 2, and then you return to A, and A has no other neighbors that haven't been checked, so then you have your level 1, 2, and 3. But can you see how, say I had a tree where it just kept going down, and just one other node there, whether or not you would just use depth first search for this entirety of it, or would you, for every distance of say 3 away, so you would go 1, 2, 3, so, and then you break out. So say you have a graph like this. Again, my question is, how are you implementing your hybrid approach? Because if you're just doing depth first search for the entirety of it besides one node, then you should just use depth first search. Creating a hybrid is probably more complicated because then you need to store the levels, and that's got additional storage complexity. But say you did something where every 3 away, 1, 2, 3, so you start with your level 1 being here, and then you do a depth first search for a distance of 3 away, which gets you up to here, and say this is X, Y, Z, Z1. You'd again correspondingly have your levels being filled out. X, level 2 would be Y, level 3 would be Z, and level 4 would be Z1. And then perhaps you return up the stack, and then you go to, say this is A, you go to A, and then A returns. And so you would, you would have A here. But then, so say you are switching off, you need to find a way, you need to write that this is unmarked, and that you need to continue to check down Z1's neighbors. But then you would again have to transverse down the tree just to get to Z1's neighbors, and then either use a breadth first search or a depth first search, which would just add more transversals down the tree if you're splitting between back and forth. Alternatively, you would go down the tree down to Z1 and then begin a breadth first search, so you wouldn't have to have those additional transversals here. You would just start right here, and then you do a breadth first search, but then you have to transverse up the tree and then check A. So in that manner, if you had separate branches of a tree, that would work. However, if we have a more complicated graph, for example, this, which wasn't a tree, just, perhaps it's got cycles in it, if you're going down these neighbor paths and then you end up finding one, and say at some point in this path you're using depth versus search, and then at some point in this path you're using breadth versus search, once you hit a cycle you have an issue, because say you were using breadth versus search in the blue, but in the green you're using depth versus search. How do you transition either back? Because say you have incomplete levels, so say level 3 has, A in it, and we're assuming this is attached to other things so that it could possibly have a level 3 to it, right? And then say breadth versus search, you're transversal, so this has this is B, and then you get transverse to Z, and then Z is attached to A, and somehow you need to show that Z is in level 4 compared to A, right? Because these two are neighbors and they're a distance of 1 apart, but it creates a cycle with B. So B and Z cannot be in the same level because they're a distance of 1 apart. So I think in that case you have a problem with transitioning in between depth versus search and breadth versus search, but these are just food for thoughts. I'm sure there could be an implementation of a hybrid search. I can't find a possible one other than a tree one, where again I think you could just possibly use one algorithm over the other. I don't know if there's necessarily an advantage, but there's certainly not an advantage when there's cycles in your graph.